Hey there, welcome to example 2. In about 10 seconds or so, I'm going to show what the table would look like, all the stuff I give you for free. But I thought I would say right now, if anyone's interested in trying to fill in the table themselves, there's another video that links right after this one that shows how I got the table filled out. So I encourage you guys to try it yourselves, but I'm about to pause the video, and when I resume the video, all the columns that you would need will be there. So if you're interested to try it yourself, pause the video now. If you want to see if you're right, look at the other video before this one, and otherwise, just wait a few seconds, and like TV magic, all the things will be there. I'm going to pause the video right now. And as promised, here are the columns that I would use to figure out the overall truthness of the compound statement listed at the top of the page there. Now, the next thing I'm going to do is, again, encourage you guys, go ahead, pause this video, copy this down, try to fill in this truth table by yourself. We are trying to determine if this statement up here is a tautology or not, meaning, is it the case that this is always true? And I am, again, going to stall for a few moments and say I'm going to pause the video. And when I unpause the video, this truth table will be completely filled in. So here's me stalling, blah, 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 blah. Here's me pausing. When the video resumes, it'll be filled in. This is what you should end up with. So feel free to pause the video right now and think it through or check your answer or however you want to do it. But I am now going to talk through how I got these values. So I'm going to pause the video, delete all this work that I just did, and then talk through how to think this through and how to use the truth table to make it easier for us, because it allows us to only focus on a few things at a time. So I'm going to go ahead and pause and delete, and when I resume, this will all be blank. And I'll be talking, hopefully not too fast. Let's see. So the ultimate goal, thanks for sticking around, by the way. If this is still confusing to you, the ultimate goal of the truth table is to allow us to only focus on a few rules at a time. As you've seen me get tied up in my own words, it can get very confusing when you're trying to think about several logic things all at once, if it's true or false, and the different rules we have. I think now is a good time to just remind you guys there really are so far only 3 rules for truthness and false. We have and statements, or statements, and what do we call them in this class? And conditionals. I'm sorry. We have and, or, and conditional statements. And what I hope everyone knows is ands are only true when both things are true. Otherwise, they're false. Right? So I would keep that in your mind. Ors are only false when both are false. Otherwise, they're true. So that's another rule I keep in mind. And then conditionals are, what's the rule? Do you remember? Conditionals are only false when the beginning is true and it leads to a false conclusion. Otherwise, they're true. So as I go through these things, I try to focus on those exceptions. Like and's exception is true, or's exception is false, and conditional's exception is false. And the different things make that happen, but that's how you're going to see me work through this. So when I'm trying to figure out this very first thing, M implies N, that's a conditional statement, I am focusing on where this is false, because that's the tougher thing to have happen. And I know it's false, and I've got to remind myself of this. This is not coming naturally to anybody in the world. That is only false when the beginning is true and it leads to a false statement. So in this case, I'm going to be looking for where is this true, but this false. So I'll start by looking where this is true. So I'm not even looking down here. My eyes don't even go there. And I see it's true here and here, and this is the one place that's going to be false. Because that's the only place where M is true and M is false. Once I found the one place where it's using that exception, I just know everything else is true. And then I put it out of my mind. And then I look at not M, and that's pretty easy. There's not a lot to think about here. Whatever the value for M is over here, I'm going to flip it to the other thing over here. So it's false, it's true, it's true. Now I got an or statement, and I got to remember what's that deal. The deal with ors are, they are only false when both things are false. So I know that I'm looking at the column that has not M, I'm looking at the column that has n, and I am laser-like focused on where are those both false, so I can mark this thing as false. Laser-like focus. If I see a true at all, I stop looking at it. So as I look at this first column, I see this true right away, I stop thinking about it. Oh, here's a false and a false. This must be false. Well, true, I stop thinking about it. Okay, so I've looked through everything. I've only seen a double false in one place. So now I'm going to go ahead and mark everything else as being true. And now for the final portion, right? Let's use red. I got to figure, I'm going to look at m implying n, implying not m or n. So the first things first, which two columns do I need to look at to figure this out? Well, I'm going to want to use this column right here, because that's the first part of the statement. And I'm going to want to use this column right here. And I am looking for the exception. The exception for conditionals is it's really hard for them to be false. They're usually true. They are only false when this is false and this is true. So this is what I have in mind. I'm going to look in this column for any place this is false. And if I find a place where this column is false, I'm going to look in that same row for this column. And if it's true there, I'm going to mark this as false. And if I don't see any places where this is false and this is true, then I won't mark any place as being false. So this is the only place this is false. And when this is false, this is also false. So I'm not marking this as false. That means all of these are true. Every single one of these is true. And that also means that this statement, regardless of how I combine the truthness or falseness of the statements that make it up, it is always true no matter what. It is a tautology. Tautology, which I should not spell without spell check. It's spelled something like that. So I hope two things from this lesson you guys get. I hope you understand what a tautology is. It's always true. I hope you understand how we would need a logic table to help us figure that out. And I hope I've helped you gain some insight into how to use a logic table and maybe even how to set one up, even though that's not really part of the class. So I got for you guys today. I'm not really sure what's going to happen next. I may have a short assignment on Classroom for you to do. I probably will. Look for it. It's possible that I won't, and I'll make that clear as soon as I know for sure. Be safe, my friends.